Hello friends, let's get familiar with the terms related to the curvilinear motion of a particle. A particle that moves along a curved path is said to experience a curvilinear motion. Let's take the Cartesian frame of reference with O being the origin. The red curved path is traced by a particle whose instantaneous position is P with coordinates x, y, z. The position vector of the instantaneous position of the particle is bold r. That is, vector OP is equal to bold r. As the discussion goes on, the bold letters denote the corresponding vectors and the light or non-bold letters denote the corresponding scalars. The unit tangent is a unit vector in the direction of the tangent drawn to the curve at point P. The unit normal is a unit vector in the direction of the normal drawn to the curve at point P. The derivative of the position vector of the particle at point P with respect to the time is expressed as follows. The rate of change in the distance traveled by the particle at point P with respect to time is equal to the magnitude of the rate of change in the instantaneous position of the particle at point P with respect to time. This is also the instantaneous speed of the particle, and this is equal to the magnitude of the instantaneous velocity of the particle. The rate of change in the speed of the particle at point P with respect to the time is expressed hereunder. It is important to note that the instantaneous speed is equal to the magnitude of the instantaneous velocity, but in curvilinear motion, the rate of change in the instantaneous speed is not equal to the magnitude of the rate of change in the instantaneous velocity. The instantaneous velocity of the particle at point P can be expressed as follows. The instantaneous velocity is in the direction of the tangent drawn to the curve at point P as shown in the diagram. The instantaneous acceleration of the particle at point P is expressed as follows. The instantaneous acceleration is the rate of change in the instantaneous velocity. As the expression suggests, the acceleration is equal to the unit tangent times the rate of change in the instantaneous speed added to the unit normal times the square of the instantaneous speed upon the radius of curvature. This is the tangential component of the instantaneous acceleration. This is the normal component of the instantaneous acceleration, and it is directed radially inward. This is the actual resultant acceleration. The instantaneous radius of curvature is equal to the cube of the instantaneous speed upon the modulus of the vector product of the instantaneous velocity and the instantaneous acceleration. The instantaneous radius of curvature can also be proved to be equal to the square of the instantaneous speed upon the square root of the square of the magnitude of the instantaneous acceleration minus the square of the rate of change in the instantaneous speed.